Welcome once again in our day's class. Today, we are going to look at Whitney U test. And this test is very important in research because it enables the researcher, after calculating the U value, to know whether to reject the null hypothesis or to accept the null hypothesis. This test, by definition, I'll say that the Mann-Whitney is an non-parametric statistical test used to compare two independent groups. And it's commonly used when the assumption of parametric tests, such as the t-tests, are not made. The Mann-Whitney U test is a powerful statistical tool for comparing the differences, and you should underline the word differences between two independent groups when the data is not normally distributed. So here, we don't use it looking for association. We don't use this one looking for a relationship, but we use this one to look for the differences between the two groups. Very important that when we are using this test, if you are looking for the differences between the two groups, then this is the test to choose. But we have also said that it is only used when the assumption of parametric tests are not made. It is based on the concept of ranks, and it's used to determine whether the two groups have different population distributions. The test is non-parametric and it's more robust when outliers are involved. The tests such as t-test will be affected by outliers, but this test will not be affected by outliers because we are using ranks. There are assumptions which must be passed or our researcher should be aware of before using this test. One of such assumptions is independent of samples. This is that observation within each group are independent of each other, that there is no sample that is going to be found in both groups. A sample cannot participate in both groups. A sample only participates in that group that has been assigned to it. We don't have a sample being picked from both groups that we are comparing. This means that the measurement of an individual in one group do not influence or do not depend on the measurement or individual in the other group. So independent samples are very important when you're using this test. When you're having your samples and you're having two groups, a sample in one group should not be also, a sample in one group should not go and participate as a sample in the other group. These groups should be independent. Another thing is that we have identical distribution. We have identical distribution. The shape of the distribution of the two groups should be similar. So if you are using, in one group, you are using 10 samples, then the other sample also should be 10 samples. If you are using 11 samples in one group, in one sample, then the other sample in the other group should be 11 samples. So they should be similar. You should not have one sample having a greater number of participants and then the other having less participants. We should have the similar participants in both groups. Another assumption is that the continuous outcome variable, the dependent variable, that we have the independent variable and the dependent variable. The dependent variable should be analyzed and should be measured at least at an ordinal scale. However, the test is robust to violation of this assumption and can be used for continuous, ordinal, or discrete data. Finally, we must also do random sampling. The observation in each group should be randomly sampled from their respective population. There should not be purposeful sampling, where you say that this one must be in this group and must be sampled in this group. You should be able to do random sampling. This assumption ensures that the sample is representative of the population, because sometimes we want these results to be applied to the entire population. And if we are going to apply this result to the entire population, then it means that we have to do random sampling. Now, I have an example here. I'm going to use an example here where we have two teaching methods. One that is technology enhanced, and another one is a tradition method. And the research question I'm asking myself in this case is, does use of technology enhanced learning tools improve student academic achievement in mathematics compared to the traditional teaching method? I'll repeat part again. I'm having a study and I have a research question. I'm using two methods, one that is technology enhanced and another one that is traditional based. So the research question I'm having is, does the use of technology enhanced learning tools improve student academic achievement in mathematics compared to traditional teaching methods? Now, in this case, I'll have students being taught by technology enhanced learning tools, and another group of students, sample, being taught by traditional teaching methods. Now, these students that are participating in one of the groups, technology enhanced learning tools, should not be able also to participate in this. These are two independent groups. So one group will be taught by technology enhanced tools, and another group will be taught by traditional teaching method. And I'll be able to see their performance, their achievements at the end, to see how they perform in mathematics. And therefore, thereafter, I'll be able to conclude and see whether the two or both of these groups are performing at the same level or there is a difference in their performance. So in technology enhanced learning group, I have student A, student B, student C, student D, student E, and student F. While in sample 2, where I have traditional teaching group, I have student G, student H, I, J, K, and L. Those students that are found in sample 1, this is an independent group as compared to the sample 2, which is also an independent group. Now, in this example, as I said, I want to investigate as a researcher the impact of using technology enhanced learning tools on student academic achievement in mathematics compared to the traditional teaching methods. And the researcher here has selected the two groups of students. And the first group, which is sample 1, receives mathematics instruction using technology enhanced learning tools, while the second group, sample 2, receives instruction using traditional teaching methods. The researcher then collects the academic achievements scores of each student in both groups at the end of the instruction period. And these are the scores that I have received. For sample 1, which is technology enhanced learning group, student A scored 85, student B 78, student C 92, student D 68, student E 75, student F 80, student G 72, student H 88, student I 76, student J 81, student K 79, and student L scored 85. Now I will move on now to use the Mann-Whitney tests to compare whether to compare the two groups to see whether there is a difference in the performance in the two methods. And this is how I will proceed, because now the achievement, or I have the achievement for both, for students from both groups. I will now therefore rank the data. That's step one. The step one, first we need to rank all the scores from both groups combined, regardless of their group membership. Now we will combine all these groups. Group one, group that use technology enhanced learning group, and the other group with sample two that use traditional method. We will combine both of them and we rank these scores irrespective of their group. So we are going to rank these scores, and this is how we are going to rank. If there is a tie in the ranking, assign the average rank to the tied scores. I will repeat that point again. If there is ties, assign the average rank to the tied scores. Let us perform this example and see what I'm referring to. So in this group, we start with the list. So the list here is 8. So this one will be rank 1. Then 6, 8 is followed by 72. So 72 will be rank 2. Then I'll move on to the next one, which is 75, which will take rank 3. Then I'll have the other one that will follow is 78 at 76, which will rank 4. Then I'll go to 78, will take rank 5. Then I will go to 80 at 79. 79 will take rank 6. Then 80 will take rank 7. Then 81 will take rank 8. Then 85, I have 2 of them. I have this one and this one here. So they are supposed to take rank 9 and 10. Rank 9 and 10. So what I will do here, I'll take rank 9 plus rank 10, and then I divide by 2. So this one will be 19 over 2. So this one will be taking rank 9.5. Because there are 2, they are taking rank 9.5. Then I still have 2 of them. I still have 2 of them because I had rank 9 and 10. Then I go to rank 11 and rank 12. Rank 11 and rank 12. This is how I do the ranking of both of them. Then after I have finished ranking, I will do the addition of each rank. I will add all these ranks together on this sample, on this side of sample 1, and I will do the same on this side of sample 2, so that I'll be able to get the sum total of the ranks. So this is it. This side of rank, my total is that 7.5. Then on the other side of traditional teaching method, the total of the rank is 40.5. 40.5. So I have the total of the two ranks. Now I will move on to apply the formula for Mann-Whitney. I'll move on to apply the formula for Mann-Whitney. And this is the formula for Mann-Whitney. So the formula for Mann-Whitney is U1 equals to N1 times N2 plus, do the numerator N1, open the bracket, N1 plus 1, close the bracket. Then to the numerator, you divide by 2, then minus R1. What are these? N1 is the sample size of sample 1. N1 is the sample size of sample 1. That is the technology enhanced learning group. The N2 is the sample size of sample 2. That is the traditional teaching group. The group we used the traditional method teaching, or the group that sat the achievement test and also participated in the traditional method of teaching mathematics. Then R1 is the sum of the rank in sample 1. R1 is the sum of the ranks in sample 1. Also, there is another formula which is similar to this one here, which U2, N1, N2 rest, where N1 is the sample size of sample 1, N2 is the sample size of sample 2, and R2 is the sample size of sample 2. Is the sample size of sample 2. Now here, I'm going to use this formula now, both formulas, so that I can now substitute in my values. So in this formula, I take both formulas and I'm going to substitute in my values. And this is what we have. In sample 1, the sample is 6. In sample 2, the sample is 6. So this was N1 and this was N2. This was N1 and this is N1 again. Now, the sum for rank 1, the sum for ranks in sample 1 was 37.5. When you do the same to the second, you'll get the same thing. This is sample 1, sample 2, sample 2, sample 2 there. Then this is the sum of the ranks in sample 2. This is the sum for the ranks in sample 2. Then when you have to do everything, you have worked out everything, this is what you'll get. 36 plus 21 minus 37.5, giving you 19.5. And the other one will give 36 plus 21 minus 40.5 will give you 16.5. So in Mann-Whitney, we use the lowest number we get so that we can be able to test our null hypothesis. We don't use the largest. We use this. We use the smallest. In this case, the smallest sum or the smallest shooted U is 16.5. 16.5. Now, step number 3, we determine the critical value and compare it with the U test we have calculated. So in this case, we get the critical values from the Mann-Whitney U tables, and we compare this critical value with the one we have calculated. So this is the table that appears on my screen. And on this table, we have N1 at the far corner. We have N1 and N2. And remember, N1, the sample size of N1, the sample size of sample 1 was 6. So we go where 6 is, and we allocate it. Then we go across. We move across. Then we have the sample size N2. The sample size for N2 was 6. And 6 is up there. I have circled it. Then we go down until the 2 are able to intersect. So we see the 2 are intersecting at 5. The 2 are intersecting at 5. So 5 is our critical value from the Mann-Whitney U tables. And this is done at 0.05. Our significance level is 0.05. There are several tables we have for Mann-Whitney. There is a table for 0.01, a table for 0.02, a table at different significant levels. But the table I'm using here is at the significant level 0.05. So the critical value for Mann-Whitney is 5 at this point. Then we put the two together to calculate the value and this value, which from the table, and we are now step 4, we interpret now. So after interpreting, we have now to report our values. We now move on to report our values. Now, how do we report our values? We say a Mann-Whitney U test was conducted to examine whether the use of technology-enhanced learning tools improves student academic achievement in mathematics compared to traditional teaching methods. The calculated U value was 16.5, and the critical value from the Mann-Whitney U table at a significance level of 0.05 was 5. Then the U value of 16.5 exceeds the critical value of 5, indicating statistically significant difference between the two groups. U calculated is greater than a critical value at P less than 0.05. Consequently, the null hypothesis is rejected, suggesting that there is a significant difference in academic achievement between students using technology-enhanced learning tools and those taught with the teaching method. Now, how do you report this one in APA? This is how you report it. A Mann-Whitney U test was conducted to investigate whether the use of technology-enhanced learning tools improves students' academic achievement in mathematics compared to teaching methods, compared to traditional teaching methods. The analysis included groups 1. So this group 1, we are going to report on the mean. We report the value of the mean of group 1 and the standard deviation of group 1 and the sample size of group 1, representing students utilizing technology-enhanced learning tools. And group 2, we also report on the mean mark of group 1 or 2, the standard deviation of group 2, and the sample size of group 2. This group representing students taught through tradition method. The calculated U value, and you report on the U value, which was 16.5, exceeded the critical value of 5 from the Mann-Whitney U table at P, which is less than 0.05, indicating a statistical significant difference in academic achievement between the two groups. These findings suggest that the use of technology-enhanced learning tools leads to improved academic performance in mathematics compared to the traditional methods. So in this, it's like a template we are using to insert our values. So the next template, I have inserted the mean, the standard deviation, and the sample so that we can have a complete picture of what we are supposed to report on. So in this table, our mean is the sample one, technology enhanced learning group. The mean is 79.67. Standard deviation is 8.26. And the end, which is a sample, is 6. And in sample 2, where we have the traditional teaching group, the mean is 8.17, and the standard deviation is 5.85, and the sample size is 6. So when we are reporting now, this is how we report it. A Mann Whitney U test was conducted to explore the impact of technology-enhanced learning tools on student academic achievement in mathematics compared to traditional teaching method. Sample 1 with mean of 79.67 with a standard deviation of equals to 8.26 and sample size 6 represented students utilizing technology-enhanced learning tools, while sample 2, which the mean is 8.17, standard deviation equals to 5.85, and sample equals to 6, represented students taught through traditional methods. The calculated U value, which equals to 16.5, surpassed the critical value of 16 or 5 from the Mann Whitney U table at a significant level, P less than 0.05, indicating a statistically significant difference in academic achievement between the two groups. These findings suggest that technology and learning tools may have an impact on student academic performance in mathematics compared to traditional teaching methods. This is how you report your findings from the Mann Whitney test that you have carried out from both samples. Thank you very much. We come to the end of this test. Please, if you have any query, you can reach me so that we can discuss further on this statistic, which is used for testing an null hypothesis given in research. Thank you. Thank you. Let's meet again. Before we move on, let me discuss advantages of this method. Mann Whitney U test does not assume that the data flow in a specific distribution, such as a normal distribution. This makes it robust and alternative to parametric test, particularly when the normal assumption is violated. And 2, it is easy to interpret the way you have seen me interpreting it. And it's widely used and it's widely available. You can get it in statistics softwares that we use in our day-to-day life. Also, we have the limitation for this process. It's less powerful than the parametric tests. And also, ordinal data is used in most cases, but we need to use this other. So we cannot use nominal data with this method. Thank you very much.